The very first confidence interval that I'm going to do is Laplace-Wald. This is a good interval typically for a large sample case. If the large sample assumptions are satisfied, then you can use Laplace-Wald. By all means, the Laplace-Wald confidence interval is the confidence interval for proportion that you did in Statistics 2023. Do we remember how we did that? No. So 100 times 1 minus alpha % confidence interval for P is simply P hat minus E and P hat plus E. We know what P hat is. P hat is 5/12, approximately 0.47. We just have to find E. Do we know what E is? What is E? So E is the margin of error. And the margin of error is always the product of the absolute value of the critical value that we find multiplied by the standard error. Standard error has a formula. I don't want to erase this. So absolute value of z sub alpha over 2 multiplied by square root of p hat 1 minus p hat over n. So that's how you find the margin of error. You don't have to memorize these, you get to have a cheat sheet on an exam, but do understand the concept. So critical value, standard error, and we know how to find this. In our problem, that, the two-tailed test that I had earlier, proportion of students who buy hard copies of textbooks, we just want to find an interval. So none of those matter to us except for alpha. Alpha is 0.05. If you plug in 0.05 here, what would you get?
0.95
times 100, so 95%, correct. So we are finding a 95% confidence interval. So we can find the margin of error easily because for alpha equals 0.05, I already know what the critical value is, correct? It is 1.96, but the absolute value. So 1.96 times, I know p hat is 0.46. If p hat is 0.46, 1 minus p hat is 0.54, divided by n in our case is 12.
Is that 0.47?
Oh. Divided by 12. What do we get for that? So margin of error is 0.2824. So the confidence interval for P is between P hat 0.47. Let's put 2 decimals. Round this 0.28. On the other side, it is 0.47 plus 0.28. Yes. And this would be 0.75, and that would be 0.19. So that is my Laplace-Wald confidence interval. Does the interval contain 0.32? Yes. So since the null value falls in the interval, we shouldn't be rejecting the null because the null value is possible. Good. So the same conclusion as the hypothesis test. Yes.
Why is it an open interval? Wouldn't it be safer to make it a closed interval?
Because we typically include the endpoint with the rejection rate. That's why. So this is the one that we've done in undergraduate statistics. So the Laplace-Wald confidence interval. To get that, all we have to do is go to Start, over to Calc, over to Tests, scroll down, one prop Z interval. One means one, prop, proportion, Z, normal distribution, which is why I kept using Z. Enter. Do we have X? What is X? In our problem, X and B are one and the same. It was 5. What is N?
12, I think it is.
12. The C level is simply the confidence level. So if I hit calculate, I get 0.13773. How is it? That value, is it 0.47 or 0.41? Did I enter it incorrectly? Enter. N is 12. X is 5. It is 0.42, not 0.47. Again, correct me if I'm a mistake. So this would be 0.14 and 0.42 plus 0.28. Well, we have to change everything. I thought p hat was 0.47. In reality, it's actually 0.42. So what is that value? So 0.27, 2 decimal places. So 0.42 minus 0.27, 0.42 plus 0.27. Yes. And that would be 0.15. Here, 0.69. Did we get 0.27?
9.
Okay. 279.
Yeah, so
Change it
then
to
it
2.
would be 0.28, because I know how to do it.
14, 28, 70. Life is perfect now. But the conclusion doesn't change. Yes, 0.32 still falls between 0.14 and 0.70. So you should not be rejecting the null. So realize immediately that something was off. The moment I did this in the calculator, the calculator does Laplace-Wald confidence interval. And if you round that to the nearest integer, you would get 0.14 and 0.70, not the nearest integer, nearest hundredth. So in our the interval looks slightly different. Do you agree? That is 0.15 and 0.72, because R doesn't use Laplace-Wald confidence interval. But you can get Laplace-Wald if you did binomial content. Doesn't have, it's probably in a different package. So R doesn't do Laplace-Wald because this is good or works better with the last sample. So what does R use? I believe R uses Wilson, or it could be Klopper. I don't know. But I am going to do Wilson interval and Agresti-Cool. Two intervals, they are very straightforward. And you will see when I do those other intervals, the interval that I get will be slightly different.